In this video, I'll be solving the first part of the second question of UPSC Civil Services Mains 2021 Statistics Optional Paper 1. So let y1, y2, y3 and so on be independent and identical Poisson random variables with parameter 1. So using Central Limit Theorem, we need to establish that n factorial is approximately square root of 2 pi n into n by e whole to the power of n for some large positive integer n. So first, like if I consider this y1, so y1, y2, and so on, yn, so they are Poisson with parameter 1 and their IID. So that means Sn, if I consider I is equals to 1 to n yi, so this follows Poisson with parameter n. So probability of Sn is equals to n is nothing but e to the power of minus n into n to the power of n by n factorial. So the mean and variance, so mean and variance of Sn are both n. So now for some large value of n, so for some large n, Sn behaves approximately normal with this mean and variance n and n. Approximately normal, approximately like a normal with parameters n and n. So that means so now like if I consider like Sn, so by using Central Limit Theorem, so in Central Limit Theorem, like as n tends to infinity, this Sn follows normal with mu n and variance also n. So now like we have to find this Poisson is integer valued and probability mass at Sn is equals to n, that is at the mean, like we have to find. So this we can find by like we can find the approximate point probability from Central Limit Theorem by finding the area of this normal density at this n along a width of, let's say, 1. So like we can approximate it as a rectangle. So let's say this is n plus 1 by 2 and n minus 1 by 2, and let's say like the length is same. So that means so we know that at n, so we are having 1 by square root of 2 pi n. So when the so at the mean, like we won't have that exponent part. So this will be probability of Sn is equals to n. So this into this 1. So basically this height or the length will be 1 by 2 pi n and the width will be 1 of this particular rectangle. So probability of Sn is equals to n is approximated as 1 by square root of 2 pi n as n tends to infinity. So that means for some large positive value of n, probability of Sn is equals to n can be approximated by using this area of the normal density by using this point probability approximation. So that means probability that Sn is equals to n is 1 by square root of 2 pi n. So probability of Sn is equals to n is e to the power of minus n into n factorial by, into n to the power of n by n factorial that we computed already earlier. So that means probability of Sn is equals to this 1 by square root of 2 pi n. So that means e to the power of minus n into n factorial, n to the power n by n factorial is approximately 1 by square root of 2 pi n. So that means n factorial is approximately square root of 2 pi n into e to the power of minus n into n to the power of n. So that means n factorial is approximately square root of 2 pi n into n by e whole to the power of n. So this, like we call it as Stirling's approximation formula. Stirling's approximation formula of a factorial formula. So yeah, so that's how like we can use the Central Limit Theorem to approximate this Stirling's approximation. So that's it for this video. We'll meet in the next video.